Hello Internet, my name is Quinn and this is Blondihacks. I'm starting a little side quest today. I've come into possession of a tin steam toy from about 1950 and we're gonna restore it, fix it up, see if we can get it running again. So let's go. The other day I was outside and my neighbor came around and said, "Hey, you like steam engines, right?" And I was like, "Heck yeah, I do." And he was all, "I have this one that I found in my basement that belonged to my grandfather. It was apparently purchased in what was then Czechoslovakia many moons ago, and he's been carrying it around and doesn't need it anymore and doesn't think it works and wondered if I was interested in taking a look at it and maybe fixing it up." And I was absolutely interested in all of those things, so here we are. This is a very typical example of these tin steam toys. You can of course still buy them today, but they've been popular since before World War II, in fact. This one has the typical stationary engine format, and they run on these solid fuel tablets from Espit. There's usually a little tray that sits in the firebox and holds onto that for safety. Usually it locks in so that kids can't tip it over and start the house on fire. And this particular kit came with all of these cool accessories. There's a line shaft and a little grinding wheel, a little dimensional lumber saw, and a little rip saw or table saw. They're all a little bit worse for wear, but I think we can fix them all up and make them work again. Of course, I wanted to attempt to identify and date this model, and there's not a lot of markings on it, but it does say made in Western Germany on the bottom, which obviously dates it to pre-1990. And there's also this little 17/4 marking on the corner, which I'm sorry is upside down. And that's key to identifying this as well. There were and still are lots of companies that make these things. There's Jensen and Walesko and Mamod. Now, I think, however, this is none of those. I originally thought it was a Walesko because of the distinctive brick chimney. The Waleskos all have that. However, my eagle-eyed patrons spotted that that 17/4 clearly identifies this as a Fleischmann. Now, Fleischmann is a company that does also still exist. It's a German model railroading company, and they used to make these steam tin toys. However, they no longer do. Once I knew what to look for, it was fairly easy to confirm with some online photos of estate auctions and so on that this is in fact definitely a Fleischmann. I was able to find other examples identical to this. Now that 17/4 also helps us date it because the Fleischmann model numbers increased over time, and the latest models before they stopped making them were somewhere in the 132/4 kind of range. So this being a 17/4 marks it as being a very early one. Fleischmann started making these models in 1950, so this is probably roughly a 1950 Fleischmann. The other thing that helps us date it to around 1950 is the fact that the boiler is made of brass. All of these companies started out making brass boilers because it's very inexpensive, and these toys are very much an exercise in design for manufacture and designed to a price point. They are essentially seeing how cheaply can you make a steam engine that still actually functions. Now, these boilers are still made of brass because the only other options are all way too expensive. Copper is way too expensive. Mild steel is expensive, heavy to ship, and isn't going to be very durable. It's going to rust over time unless you make it quite thick. And stainless steel is very difficult to manufacture with and also very expensive. So brass is really the only choice. Now, the modern companies, however, are very clever with this. They now nickel plate the boilers. And that's clever because, well, A, it makes them look nice, but B, it creates a barrier between the brass and the steam inside. If you watch my channel, you know that brass is not a great choice for boilers because live steam leaches the zinc out of the brass alloy and causes it to get brittle over time. More on this in a bit. The filth coming off of this thing is really remarkable. You'd be forgiven for thinking, wow, that's really dangerous. Why would they ever do that in a children's toy? Well, this was the era of radioactive material being in kids' toys, and if you're my age, you grew up with lawn darts, and let me tell you, I had a few close calls with those things. Safety standards in toys used to be a little bit looser, let's say. However, the other reason this isn't really that big a deal is because while dezinkification is real, it takes a long time, and these toys aren't really ever going to be run that much. Most people would buy them and run them a few times and go neat and then put it on the shelf. Even serious model engineers back in the day did used to make boilers out of brass because there weren't a lot of other good options available for the hobbyist. However, nowadays that's not considered safe anymore, and we wouldn't do that anymore. But like I said, people did used to make boilers that way, and if you knew what you were doing and you were careful with them, it wasn't necessarily the end of the world. But again, I wouldn't do it today. The boiler is the obvious place to start with my restoration efforts. If the boiler is no good, then we're certainly going to need to deal with that first. And well, to even figure out if the boiler is any good, I need to clean it up because this thing is filthy. I have seen a lot of these steam toys and I have never seen one this dirty, which is a good thing. That means that somebody used this thing a lot. My neighbor's grandfather clearly had a lot of fun with it. I don't think I've ever seen one that was clearly operated this much. With the boiler clean, I can now do some inspection on the joints, see how things look. And well, there's certainly some interesting evidence of shenanigans on the bottom. You can see there's solder running out of the joints all around the bottom. So this could mean one of two things. Either the boiler was run dry and thus overheated, and that caused solder to flow out of the joints, or it started leaking at some point and this is somebody's repair. It looks more like the former to me, but it's hard to know for sure. Otherwise, the seams look okay. I can still see solder in most of them. Some of them it's hard to say for sure, but it looks like all of the factory solder is probably mostly intact. And interestingly, there's some very, very old and very gross water inside it. I emptied that out, and it's a very strange color that suggests some sort of Martian extremophiles have been living in there. Probably best not to think about that too much. Also, somebody has jammed this bolt in the top of it for some reason. I think we'll get to that also in a second. There's a bunch of crud in that. This would have been the fill hole. I attempted to take a look inside, but I can't actually see anything in there. It's just too dark and there's not enough of an opening there. Looks like these fittings, like the whistle and the steam feed pipe, are both soldered in place. I wasn't sure if they might have boiler bushings or if they were soldered directly to the shell or how that might work. But it looks like they are soldered. Going back to that reference photo for a moment, you can see that that center hole was also supposed to have a safety valve in it, and that has been removed and replaced with this bolt. So that could mean a couple of things. Maybe the valve was leaking, which was keeping it from building pressure, keeping the engine from operating, or the valve was lost or damaged in some way. And, well, that is a 1/4-20 bolt, but that is not a 1/4-20 hole. This is, of course, German and thus metric, and that is, in fact, at least M61, or it might be M6.75. There's not enough threads in there. The threads are so shallow, there's only about 1.5 threads in there, that it was hard to say for sure. This is not too surprising. Those of us who live in mixed system countries have seen a lot of 1/4-20 bolts jammed into M6 holes over the years, and vice versa. Now, the reason I care about this thread, however, is because what I'd like to do first on this boiler is do a hydrostatic test on it, which means I need to make some fittings for it that will thread into this hole. I grabbed some hex bar stock and went over to the lathe. I'm going to make a threaded bushing that goes into that hole. I'm going to make it M61 because my thread checker at M61 did thread far enough in. Because the thread is so shallow, there's only about 1.5 threads in there, and they're damaged from that bolt being jammed in there. I really can't tell for sure if it's M61 or M6.75, but M61 seems to work, so I will go with that for now. And what I'm doing here is I'm making a fitting that's going to thread into that hole and allow me to attach a pressure gauge and a hydrostatic testing pump. I'll start by cutting a 1/2" 20 threaded hole in the top of it. That size chosen because I have a funnel that fits in that size, and I have a number of other threaded plugs from other boiler projects that will fit into that. Interestingly, the presence of a safety valve is not a given on these models like you might think it would have to be. A lot of the early ones actually used the decorative whistle as the safety valve. The whistles are designed such that they don't seal perfectly, and they would start leaking pressure somewhere around 10 psi, and thus keep the boiler from ever building pressure beyond that, as long as you're using the given solid fuel tablets, which build heat at a known rate, so they can determine how much the whistle needs to leak in order to keep the pressure from building above whatever the boiler is designed for. Later models didn't rely on that anymore, in fact went to a dedicated safety valve, but as we'll see in a minute, I think this particular model might have been doing both. And that's why jamming a bolt into where the safety valve was might not be as stupid a thing to do as it seemed. Flipping around to the other side now, I'm going to put an M61 thread on this end. and that will thread into the top of the boiler. I'm also putting a shoulder above that that will sit on the clearance area around the thread so that we can see what we're doing, and then I'll put a chamfer on the whole thing as well because, well, chamfers are what separate us from the animals. Now I have to give my little speech because many non-steam folks watch these videos and they look at something like this and they think, well, I would just put some compressed air in there and make sure that the boiler is safe to hold pressure. No, 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 no. Please don't do that. That is very dangerous. Compressed air is a spring. It stores energy. And if a seam on a boiler fails while you've got a bunch of compressed air pumped in there, it's going to explode and hurt you, potentially very badly. What we do with boilers to test them safely is called a hydrostatic test. We fill it all the way up with water because water does not compress and thus does not store energy, and then you pressurize that water. And then, if a seam fails on that boiler under pressure, the first 3 rows get wet and nobody gets hurt. So if you've got an old boiler like this of unknown condition, especially one with a couple of sketchy looking seams on it like this one, the first thing you should do is hydrostatically test it before you put any kind of heat source on it or compressed air into it. If you're wondering how to do a hydrostatic test, well, stay tuned. Incidentally, hydrostatic testing is also used for testing other pressure vessels for safety, such as air compressor tanks. If you buy an old air compressor, you want to know how safe it is, hydrostatic testing is the way to go for that as well. Now that I've put the threads on there and I drill a hole all the way through, this is now officially a plumbing fitting. I'm going to be able to thread that into the boiler and thread my pressure gauge and fill plug on top of that, and we are ready to hydrostatically test this thing. Or at least we're almost ready, because of course we have to block off all of the other openings on the boiler in order to be able to build pressure in it. That's going to be a little tricky in this case because remember I talked about the whistle and how they are often designed to bleed pressure. And this one is in fact doing that to some degree. If I blow some air in there, you can see it's coming out the whistle. So that whistle is going to prevent us from doing a proper hydrostatic test. Now that thing is a little tricky to block off because it's a weird shape and I can't remove it because it's soldered on. However, measuring the diameter of that, it's dead nuts 5 millimeters because Germans. So if I can wrap something around that entire thing, I might be able to block it off. I grabbed a piece of scrap and I drilled a hole in it a little bit larger than 5 millimeter. And now I'm bandsawing a slit all the way down the length of that, which will give me a little compressible bushing that will fit over top of the whistle. And then I found this little piece of gasket rubber, and the hope is that I can place this over the opening of the whistle, because it's kind of a funny shape, and kind of clamp this collar around it and seal up the entire thing all in one go. That rubber is a snug fit on there, and it'll be held in place by a Starrett 709 Toolmaker's hose clamp. Is that going to work? I don't know. Maybe. We're about to find out. Now, weirdly, that was the easy part. The other thing that we have to cover up is this steam feed pipe. This is kind of like a little flare fitting. Not really a flare fitting, but, you know, similar. And it fits into the valve body on the cylinder like so. Now that is going to be tricky to cover up. I couldn't really think of a great way to do that. I kind of settled on this. I've got more rubber stretched over the end of it, and I've got this block that I drilled a hole in and then cut in half the same diameter as that tubing, and I'm hoping I can kind of clamp it over the rubber to hold the rubber in place, and then the rubber will seal the end of the tube. Yeah, spoiler alert, this didn't really work very well, but I found something else that did work. For a proper hydrostatic test, we need to make sure that none of the test apparatus is leaking, because of course the goal is to see if pressure bleeds down when you attempt to build it in the boiler, because that'll tell you if something's leaking, and well, that's invalid if all of your test apparatus is leaking. So Loctite 545 on all the joints, and now let's fill this thing up with water. As I said, the goal is to get as much air out of the system as possible. The less air there is in it, the more accurate and safer this test is. I had removed that rubber from the steam feed pipe to let the air out while I was filling it, and now I'll put that contraption back on. Although as you'll see in the actual pressure test, what I ended up doing was just putting my thumb over that piece of rubber. Because that feed pipe is such a tiny diameter, the actual force on that rubber is very low. Remember, it's pounds per square inch, and the square inches in this case is extremely tiny, so it was no trouble at all to hold my thumb over that and keep the pressure back. Now I can get my feed water pump attached. This is my long-suffering, kit-built hydrostatic testing pump. It's also a feed water pump for boilers, The actual pump doesn't need to be very skookum. It actually doesn't take much of a pump to build up hundreds of psi, and we don't need to pressurize a very large volume. The goal for a hydrostatic test is to go to 2 times working pressure for a new boiler, or typically 1.5 times working pressure for a regular maintenance kind of check on an existing boiler. Now, finding out what the working pressure on these boilers is a little tricky. The companies are very cagey about that. They won't actually tell you, probably for legal liability reasons, something like that. However, these engines have quite a robust fan community, and fans have determined that, for example, for the Wilescos, the working pressure is somewhere around 15 psi. And apparently the people in the know say that they were factory tested to 60 for the post-war models. Some of the pre-war toys were tested to 100 psi. More on that in a second. I'm going to test this to 60, which should be plenty. This thing should, I'm sure, not operate any more than 10 or 15 psi. So if I test it to 60, that is lots. In this case, I'm using the check valve in the pump to hold the pressure. So as long as I don't pull back on the handle, the pump can hold the pressure in the boiler and allow me to check for bleed down. For anything more than 50 or 60 psi, you really need a proper dedicated check valve on the boiler for this test. But for this little toy test up to 60, using the pump strategically does work okay. And as you can see, that thing is holding pressure like a champ. I am surprised given the state of it. But that is holding 60 psi, no problem. There is no evidence of bleed down in that at all. No leaks, no drips on any of the seams anywhere. Everything's bone dry, so honestly, it really seems like it's fine, at least from a pressure testing standpoint. It doesn't necessarily mean it's safe to operate, as we'll see in a bit, but it certainly passed a pressure test with flying colors, which really surprised me. I fully expected it to fail this test, and then we were going to rebuild the boiler, and that was that. However, things have gotten a little more complicated now because it's kind of passing the tests. Now that I know it's safe to hold pressure at least, I decided to get out the compressed air and I wanted to test that whistle. At this point, I wasn't sure if it was supposed to have a safety valve or not. I had not seen those pictures yet that I showed you with the safety valve on it, and information on these old Fleischmann engines is much more difficult to find than the Wilescos, the Mamods, and the more popular ones. Again, safety first when working with boilers. I can put compressed air in this safely because it has passed a hydrostatic test. I know it is safe to hold pressure up to 60 psi. And I've got a low pressure regulator on here. I'm only going to be putting 10 psi in this thing. I just want to see what that whistle is going to do. This was actually really interesting. I pressurized the boiler and I eased that regulator up from 5 psi to 10, just seeing what it would do at each stage. And look at what happens. The boiler pressurizes up to 8 psi, but no further. The regulator is set to 10, so the compressor is putting 10 psi in there, but it's only building 8. And that's because the whistle starts leaking at 8. If I shut off the valve, regulator bumps up to 10 because it's pressurizing the air nozzle. Then when I open the nozzle into the boiler again, it won't pressurize past 8 or maybe 9 psi, and the whistle starts leaking down. So that's pretty cool. That does in fact seem to confirm that this model of steam engine toy was using the whistle as the primary pressure limiting on the boiler, but the safety valve was there as a backup. So this engine is probably designed to run at 8 or 9 psi, and the whistle was kind of self-regulating it. So that's pretty neat. I really thought that was cool. I don't know if that's for sure by design. Maybe the whistle is just old and it's just leaking. I don't know. But that at least explains why the original owner felt fine putting that bolt in to replace the safety valve, because the whistle was limiting the pressure anyway. At this point, I had a tricky decision to make, however. Should I sweat these seams apart on this boiler and redo them? While it did pass a pressure test, there is evidence of past damage to this boiler. Either those joints were overheated, in which case they can't really be trusted even though it has passed a single pressure test, or it's been repaired and I don't know for sure if it's been repaired correctly. The other thing to keep in mind here is at this point, I thought this was a Wilesco, and a key detail about Wilescos is that they were all soft soldered, which is, again, not something we would do as model engineers. You'd never soft solder a boiler because you're typically running them at temperatures that are above the soft solder melting point, so that wouldn't be safe. However, a lot of these steam toys were soft soldered because it's, of course, much cheaper. And if you're only operating below, say, 20 psi, soft solder is okay because the boiler isn't getting that hot. boiler pressure is a function of how much heat is in it. And as long as the boiler has water in it, those little S-bit tablets don't burn hot enough to melt soft solder. Given all this information that I had at the time, I decided I would sweat this thing apart and redo the joints because with soft solder, that's quite easy to do, so there's really no reason not to. However, had I known this is a Fleischmann, and Fleischmann silver soldered their joints. And I found this out the hard way when I attempted to sweat all these joints apart, and it was requiring a lot of heat, way more than it should have for soft solder. And just given my experience working with the two kinds of solder, you could see how it was behaving. This was clearly silver solder. So kudos to Fleischmann, they made a much better product than Wilesco did, at least in 1950. And I would not have attempted this if I'd known, because silver solder is very, very difficult to sweat apart once it's been assembled. But in the end, this turned out kind of for the best. I was attempting to pull the head off of this end, and I was making progress, it was moving, and then something very interesting happened. Pretty unexpectedly, a hole appeared in the material, and I stopped to inspect what was going on here, and this brass in this area is brittle like plaster, and that, I believe, is dezincification. It isn't bending or deforming in any way, it's just crumbling when you touch it. And you can see how much solder was in that joint. There's, just solder running out of everywhere. There was so much solder in there, but the brass is really very, very fragile. It's very brittle, and that is not how brass is supposed to behave, so I think this is probably dezincification, which would make sense because we know from how filthy this thing was that it was used a lot. Way more than I think most of these toys ever are. At this point, the boiler is not fixable, that much is clear, so I decided to cut the head off and let's get a look at the inside of it. You can see the boiler bushing that was in there for the fill plug, and look at this seam. Again, it's just tearing and crumbling apart under a little bit of force. And this is, again, not how even brass this thin, this is very thin material, but even brass this thin does not behave that way. You can see that the silver soldered seam next to it is still intact, but the material, the brass itself, is just crumbling when you put any tiny amount of force on it. So I think this thing is all probably embrittled by dezincification, and it was probably not safe to operate. It may well be that's why the repair was attempted on it, if that is what happened. Possibly it was leaking because the brass was starting to crumble, and they tried to patch up all the holes with solder, maybe not realizing that dezincification was the cause. It's hard to say any of this for sure, it's all speculation. One thing we can say for sure is this toy is getting a new boiler. This one is not fixable regardless. So I'll finish taking it apart and see if there's anything we can salvage. You can see the boiler bushings there for the steam fill pipe, it's kind of neat. And the whistle actually seems to be in pretty good shape. I'll definitely try and save that. It actually turns out to have a valve on the side of it. I thought this little arm was decorative, but it in fact turns, and there's a little orifice in the inside that rotates to turn the whistle on and off. Well, let's see if it still works. It's a little hard to hear over the air itself, but there is a very, very high-pitched whistle coming out of it. Very high-pitched, of course, because of how small it is. So the whistle does in fact still work. I'll definitely be reusing that on the new boiler. Well, a bit sad perhaps that we couldn't make the original boiler work, but as I said, I think it's for the best. I don't think this boiler was likely safe to operate. I mean, it is 75 years old, and these toys were absolutely not intended to last that long or endure as much use as this one clearly has. So it's getting a new boiler, but that's going to have to happen in a future video, so stay tuned to more of this series. Thank you so much for watching, thanks to my patrons for making it all happen, and I'll see you next time.